Hello, this is a tutorial on how to conduct a one sample t-test. So we have a data set here that involves looking times from infants for different kinds of pictures. And one thing we want to know is if in experiment one and experiment one only, the baseline proportion looking at singers when comparing two different pictures prior to hearing songs, if it was similar for the two different pictures. In other words, looking at proportions, we would want this particular measure here to be 0.5, or half the time they'd be looking at one side, half the time they'd be looking at the other, because that would be indicative of chance looking at each side. So we are first going to split the file. So we're only looking at experiment one. Go to split file, experiment one. Okay, ignore that out, but that was something else. Then what we're going to do is go to analyze, compare means and proportions, one sample t-test, and click on baseline proportion gaze to singer. Now remember, the value that we are interested in is how similar or how different it is from 0.5, because that would show an even split in gaze. So our test value is going to be 0.5. Your decision of what the test value is will depend on what's an important value for making a comparison with the variable of interest. Then you'll click OK. And we're only interested in experiment one. So we'll go down here and we see that we have a sample size of 32. The mean is 0.52 and change, which just looking at our descriptive statistics, we can guess that that is not going to be significantly different from 0.5, especially with the standard deviation being approximately 0.18. That is a relatively large standard deviation if we would think that 0.02 would be a meaningful difference. So we have a t-value of 0.674. That's a pretty small t-value. So it's not surprising that when we look at the two-sided p, it is 0.505, which is substantially higher than the alpha level of 0.05 that would indicate significance. So this is not significant. Our degrees of freedom are 31 because our sample size is 32 and we lose a degree of freedom for every test we conduct. So in this case, we would say that the t with degrees of freedom of 31 equals 0.67 with p equals 0.51. We very rarely look at a one-sided p, and in this particular situation, I can't think of any reason why, when you're looking for an even split, you could justify a one-sided p. It's extremely rare to see that reported in the literature. So as a rule, focus on a two-sided p-value.